You're looking at the spreadsheet which I developed to calculate, or I should say to graph, a sine-generated curve. Using the convention that I do for the coloration of the cells, the yellow is the user input and the blue are calculated. Now a lot of these are calculated here, but I did not color all the cells in. So for this particular example, we're talking about looking at the channel meander in the plan view. So in order to do that, we need to know the meander arc length and the sinuosity. Once we know those two parameters, we can calculate the meander wavelength and the maximum deflection angle, either first in radians from the equation, then if we need to visualize it in degrees, we can put it into degrees. So this particular, to go from radians to degrees, as you can see, you can use the function just degrees of cell D7. So then I select the number of line segments that I would like to split the meander arc length into in order to determine the x and y coordinates. I then determine once I'm done with the table, I can determine this as the meander amplitude. And you can see it's just the maximum value over that column from C14 all the way down to C214 and minus the minimum. That will give me the meander amplitude. The radius of curvature I compute from the equation from Langbein and Leopold. So here is the S, which is the distance along my arc, and then the deviation angle is calculated from the equation from Langbein and Leopold. And then using the trigonometric relationships, which were shown in file NC-210, I come up with the x and y coordinates for the meander arc length, which is right along the arc itself. I then plotted these two columns to come up with the channel meander using a sine-generated curve. Notice the meander arc length repeats itself, and within the meander arc length you have two riffles, two runs, two pools, and two glides. If you wanted to start at the bottom, you're starting from the glide and you're working your way around until you finish in a pool. But this then would be the plan view of the channel meander. What you'll be doing for homework, you're going to get the student version of this, and you'll be able to come up with the equations for actually the production of the meander curve graph.